important questions from previous year questions. Mole concept. Come on, let us discuss the first question. 6.02 into 10 to the power of 20 molecules of urea are present in 100 ml of its solution. The concentration of the solution. So indirectly they are asking about that molarity. Concentration of the solution, it is nothing, molarity. So molarity is equal to number of moles of solute divided by volume of solution in liter. Volume of solution in liter. Right. Okay. Now, what are the datas? Let us discuss so that we can apply the values in that formula. Okay. Now, datas, what are the datas they have given? 6.02 into 10 to the power of 20 molecules of urea. So, how much molecules it is? 6.02 into 10 to the power of 20 molecules of urea. Volume of solution, how much they have given? Volume is equal to 100 ml. Okay, now number of moles we have to identify. Okay, number of moles, how to identify? So 1 mole equal to 6.023 into 10 to the power of 23 molecules, right? Molecules. Therefore, 6.023 into 10 to the power of 20 molecules equal to 1 by 6.023 into 10 to the power of 23 into 6.02 into 10 to the power of 20. Okay, now this and this will be cancelled. So remaining how much? 10 to the power of minus 3. So number of moles of solute, it is 10 to the power of minus 3. Right. Okay, now the next point, volume we have to identify. Volume of solution in liter. So volume of solution, what data they have given? 100 ml. So converted into liter. This is multiplied with 10 to the power of minus 3, volume of solution in liter. So that is 100 divided by 1000. Right. So 10 to the power of minus 3. So we can get this is liter. 100 into 10 to the power of minus 3. Okay, now can we apply the values, these two values? This is number of moles and this is volume of solution in liter. Right. Now here M, capital M, molarity is equal to 10 to the power of minus 3 divided by 100 into 10 to the power of minus 3. So this and this will be cancelled. Remaining how much? It is 0.01. That is capital M. Hope you got the clarity. Now, which is the correct option? Come on, let us go and identify 0.01. Option C as the correct option. Option C. This is the correct option. I hope you got the clarity. How do we identify? First and foremost, as you read the question only, you will come to know what type of question it is and you should check that formula. Then apply the data. Then you can get the answer according to that. Hope you got the clarity about this question. 0.01 is the correct option. Option C. Come on, let's go to the next question. Next question, equal masses of hydrogen, oxygen and methane have been taken in a container of volume V at temperature 27 degrees Celsius in identical condition. The ratio of volumes of gases, hydrogen, oxygen and methane. So here they have given the ratio of volumes of gases. See, Avogadro's law, what it has mentioned, number of moles equal to volume of that gas. Yes, come on, let us find the ratio of volumes of this gas. Okay, now here, hydrogen, oxygen and methane, right? So number of moles, okay, moles of what it is, N hydrogen and moles of N oxygen and moles of methane, right? Moles of N methane, CH4, right? Okay, now CH4 it's methane, right? Okay, now here moles means number of moles equal to given mass by molecular mass. Okay, now just we can identify small m by capital M. Small m, it is given mass, capital M, it is molecular mass. So molecular mass of hydrogen H2. So how do we bring it over here? So that means here small m by 2 I just mentioned. Why I'm mentioning 2? Because molecular mass of hydrogen H2, it is 2. And the same way here also small m by oxygen. So that means here what it is, small m by 32. I hope you got the clarity, molecular mass of oxygen. And the same way here small m, this is capital M, and then same way here what it is, small m by capital M. I just mentioned with the formula so that it will be, as we are going to write it fast in a smart way, you know how to write it. That is CH4. CH4 equal to what it is, small m by 16. What is the molecular mass of methane? 12 plus 4. It is 16, right? So that is what I just mentioned. Okay, now let us find the LCM of each. That is H2 is to oxygen is to, what is that ratio? It is CH4. Right. Now here what it is, 1 by, it is actually 2 is to 1 by 32 is to 1 by 16. Let us take the LCM of these three, 2, 32 and 16. If you are taking LCM, right? LCM, how much you will be getting here? Actually 32. I'm getting 32. Okay, now you just check it whether it is correct or not. So 32. Now how do we apply these things? So 1 by 2 into 32 is to 1 by 32 into 32 is to 1 by 16 into 32. Okay, now here, how much you are getting? Here, actually, the first one, what it is? 16. Right, the second one, 1. And this third one, it is 2. So, what is that ratio here? 16 is to 1 is to 2. So, this is the volume of the gas ratio. 16 is to 1 is to 2. Please check it LCM. It is very simple. Like how you can calculate. No, that is what purposely I just mentioned. So, 16 is to 1 is to 2. Yeah. Answer C. It is blinking. Yes, I am here. Answer is here. C. 16 is to 2 is to, sorry, 16 is to 1 is to 2. So, this value, it's a correct option. Hope you got the clarity. And Avogadro's law tells about what it is. Number of moles is equal to equal volume of the solution or equal volume of the gas, right? Okay, that is what here also volume of the solution. So here number of moles equal to volume of the gas. So that is what I just mentioned. Okay, hope you got the clarity about all these points. How do we go for it? How to identify? Yes, come on, let's go to the next question. And 22.4 liter of H2 gas mixed with 11.2 liter of chlorine gas, each at STP, the moles of HCl is formed is equal to, so which is the correct option. Okay, so before finding the correct option, let us write that balanced chemical equation so that it will be easy for us to identify. Okay, H2 gas, this is actually H2 gas plus Cl2 gas. It gives 2HCl. This is a balanced chemical equation. So here everything gas only. So this is 1 mole of hydrogen combined with 1 mole of chlorine. It gives 2 moles of hydrogen chloride. Okay, now here volume they have provided, right? So volume they have provided means at STP. So the conditions also they have provided. Okay, so at STP, volume of 1 mole, volume of 1 mole of any gas is equal to 22.4 liter. So even volume also they have provided how much. Why I'm bringing this point to you? Avogadro's law, what it has mentioned, number of moles is equivalent to volume of the gas, right? So that is what I just mentioned. Here volume, how much they have given? 22.4 liter of hydrogen gas mixed with 11.2 liter of chlorine. Okay, so here 1 mole of chlorine can provide 2 moles of 1 mole of chlorine can provide 2 moles of HCl. Therefore, here they have given what it is 11.2. But generally, STP volume it is what it is 1 mole of any gas, that is 22.4. But here 11.2. So that 11.2 means what it is? It is half of that. So that means here 1 mole, I just bring it here, 1 mole of chlorine can provide 2 moles of HCl. Therefore, 0.5 mole of Cl2 can provide how much mole of HCl? That's all this question. Here, how much moles of HCl? See, here mole is equivalent to volume of the gas, right? So that is what at STP volume of 1 mole of any gas 22.4 liter. Right now here, that means here one more point also I wanted to mention. This is LR. What do you mean by LR? You know, this is limiting reagents. That is limiting reagent means which is consumed completely. That is called limiting reagent. So which is excess? This is excess. This is excess. This is least amount. So that is what limiting reagent we are telling. So in this amount only the reaction is completed. So 1 mole of Cl2 it provides 2 moles of HCl. Therefore 0.5 moles of Cl2. That is what it has given 11.2 liter of HCl. Well, what it is? Moles of HCl formed is equal to, that is what, so 11.2 liter of chlorine if it is combined with 22.4 liter of hydrogen, how much HCl it is formed? So 1 mole of Cl2 can provide 2 moles of HCl. Therefore, 0.5 moles of Cl2 it can provide how much? Here simple cross multiplication. So 2 moles divided by 1 mole. Okay, so 2 mole it is what it is? 2 moles of HCl and 1 mole of Cl2 into what it is 0.5. You can directly you can write, but steps I'm giving. Okay, now how much you will be getting? Here when you calculate it, you will get 1 mole only. Right, if you calculate that, that is 1 mole only. Right, so which is the correct option here? First answer only, it's blinking. Yes, I am there here. 1 mole HCl. This is very simple, logical way thinking. Directly you can find the answer. Why I'm bringing all these points? Because for you to understand, suppose the value changes, you can apply these kind of steps so that you will get the answer. Hope you got that clarity. Come on, let's go to the next question. And 1 gram of magnesium is burnt with 0.56 gram of oxygen in a closed vessel. Which reactant is left in excess and how much? This is very simple. If you write that balanced chemical equation, you are able to identify very clearly. Come on, magnesium, what it is? Magnesium, Mg plus oxygen, O2. It gives MgO. It is not balanced, right? So 2 MgO. Now, is it balanced? Yes, it is balanced. Now, let us write the data. 1 gram of magnesium. See, this is 1 gram of magnesium. That is a given mass. 1 gram of magnesium burnt with 0.56 gram of oxygen. So, you are getting this 2 moles of MgO. Right. Now, they have given atomic weight also. So, well and good. Sometimes they will give that atomic weight also. Okay. Now, let us write. So, atomic weight. Here, actually, what it is, atomic weight of magnesium, it is 24. And here, 2 moles, no? So, 2 into 24. So, you are getting 48 gram per mole, right? And the same way, oxygen, O2, 16, 2 into 16, here 32 gram per mole. Okay, now let us write that step so that it will be easy for you to understand. So 1 gram of magnesium, here 1 gram only they have mentioned, no? So 1 gram of magnesium, here 1 gram of magnesium reacts with what it is, 32 gram of oxygen. Right. So here how much you will provide? So 32 divided by 48. Why I mentioned 1 gram? So if you calculate this, you will come to know that result of 1 gram of magnesium, how much it is providing. So that we can go for that, what it is, 48. Right. So that means here 1 gram only, first of all, they have given. That is what I just bring it this point to you. So what is the answer you will be getting when you are calculating? 0.67 grams. So 1 gram of magnesium reacts with 32 gram of oxygen. Therefore, here what can we bring it? The same idea. 1 gram of magnesium reacts with 0.56 gram of oxygen. What is the answer? That's all. Cross multiplication. So here 32 gram of oxygen plus 48 gram of magnesium, you will be getting what it is, cross multiplication. So that means here what it is, 32 divided by 48 and into, therefore we are bringing another point over here, 0.56 gram of oxygen. Okay, so 32 gram of oxygen and 48 gram of magnesium, you're getting this much, means therefore 0.56 gram of oxygen. So here 10 apples cost that 1 apple, so that is what the same idea. So 0.56. So what is the answer you will be getting? What is the answer when you calculate it? You will be getting 0.84 gram. So here actually what it is, 48 gram of magnesium reacts with 32 gram of oxygen. That is how much it has provided, 0.56 it has provided. So that means here actually 32 gram only it has mentioned, but actually how much they have provided, 0.56. That means which is the least amount, oxygen only least amount. So that means which is that limiting reagent, oxygen only limiting reagent. What do you mean by limiting reagent? Which is that least amount completely consumed, that is called limiting reagent. You got this point also over here. Now how much it is remaining, now that point we have to bring it. So this answer, it is what it is, this point it is oxygen and this point it is magnesium. So magnesium, remaining magnesium we have to check it. So remaining magnesium how much, 1 gram, it is actually initial, minus 0.84 it is used. So this is gram, here also gram, here minus. So that means how much it is left, how much left it is, 0.16 gram. It's a remaining of magnesium. Hope you got the clarity. So this is actually given mass, molecular mass, number of moles. In that way also you can go well and good, that is also, but it is taking a time. For that is the reason I just bring that balancing equation in that here moles also I just mentioned here, balancing equation in that way, moles of atomic mass. So you are getting what it is, 48 gram per mole, 32 gram per mole. So that when you calculate it, you are getting 1 gram of magnesium, you got the answer. Now 1 gram is showing this much, means 0.56 gram of oxygen shows how much. That's all. So you are getting that what it is, magnesium value. So magnesium value only, this is actually, what is that magnesium value? It is actually 0.56 gram of oxygen can take part in 0.84 gram of magnesium. Hope you got the clarity. See here actually what it is, 48 gram of magnesium combined with 32 grams of oxygen. Here what they have given in this data, 0.56 gram of oxygen. So 0.56 gram of oxygen combined with 0.84 gram of magnesium. That is only, so limiting reagent this only. Right now come on, which is the correct option? 0.16. How do you got this? Remaining. So initial minus final value, this is. Okay. Right now, what is the answer you are getting? The answer it is A, blinking over here. The first answer. Yeah, 0.16 gram. Right. I hope you got the clarity. How do we identify? Come on, let's go to the next question. Gases contains H2 and O2 gases in the ratio of 1:4. What is the molar ratio of the two gases in the mixture? See, previous question also the same as it is here, which is the correct option. The same idea we are going to follow. So here H2 and oxygen. So H2 and oxygen, how do we identify? Previous question also I have given that idea. So please check it once again if you are having doubt. Directly I am applying the value. So 1 by 2, I just mentioned 1 by 2, it is given mass by molecular mass. So 1, it is given mass like small m. So I just mentioned it is 1 divided by molecular mass of hydrogen. And the same way here, this is 1 by 32. 32, it is a molecular mass of oxygen O2. Right now, LCM, we have to take it. LCM, it is 232. So what is the LCM you are getting actually? Here you are getting 8. So that means, 8 you will be getting. So 1 by 2 into 8 is to 1 by 8 into 8. Right now, here, this is what it is, 4. And this is 1. So 4 is to 1 is the value. I hope you got the clarity. Simple one. Already you have gone through the question in the previous question. Also the same. Only values are varying. Concept it will be same. And molar ratio of the gases, number of moles. That is also another idea, number of moles. And if suppose if they are giving gas, it is Avogadro's law, number of moles is equivalent to volume of the gas in liter, right? Okay, come on, let's go to the next question. Water molecules is maximum in? This is a repeatedly asking question, and this is very simple. Yes, here 18 gram of water, 18 moles of water, 18 molecules of water, 1.8 gram of water. Here they have asked about number of water molecules. See here, given mass by molecular mass, that is number of moles. So here I wanted to mention again and again, here number of moles is directly proportional to number of molecules, right? So here, one by one, let us go for it. So option A, what it is? 18 gram of water. So given mass by molecular mass, number of moles is directly proportional to number of molecules. So 18 gram of water given mass by molecular mass, what it is? Water molecules, you know very well, 18 only, that is gram per mole, right? So what is it? You will get 1 mole. 1 mole equal to what it is? 6.023 into 10 to the power of 23 molecules, right? Okay, now the second one, option B, what they have asked here, 18 moles of water, 18 moles of water. So 18 moles of water, they themselves have given the answer. So 18 moles of water, this is moles of water only, we have asked, we have got that first one. So moles, number of moles is directly proportional to number of molecules. So here 18 into Na, what it is? Na, Avogadro's number. Here 1 into Na, that is Avogadro number. This is option A, this is option B. Right. Now, option C. What is it, option C? Option C, it is here what they have given, 18 molecules of water. So 18 molecules of water in the question also, what they are asking about, 18 number of water molecules is maximum. So water molecules here, 18 molecules. 18 molecules. Here we no need to mention Avogadro number because 18 molecules only directly they have given the answer. Then next, fourth one here, 1.8 gram of water. So 1.8 gram of water here, D, it is 1.8 gram of water divided by 18, it is gram per mole of water. So here what you will get, 0.1 mole, that is 0.1 mole, and that is 0.1 into Na. What it is? Na, Avogadro number. Now, which is maximum molecules? The number of molecules maximum will be what it is? 18 moles. So, which is the correct option? 18 moles of water. So, 18 into Avogadro number. This is 1 into Avogadro number. And this is 18 molecules. And the last one, 0.1 into Na. So, which is the correct option? Option B. So the credit goes to option B. The answer, it is option B. Hope you got the clarity. How do we identify? Yes, come on. The next question, it's very simple, but the way they are asking the question, it is really tricky. Right now, 6.023 into 10 to the power of 23 mole inverse to 6.022 into 10 to the power of 20 mole inverse. This would change. So here they are actually 1 mole equal to 6.023 into 10 to the power of 23 mole inverse. 2, that means converted to 6.022 into 10 to the power of 20. So normal Avogadro number has changed. This is a changed one, converted one. This would change in. So what are the points to be noted down here? The ratio of chemical species to each other in balanced equation. The ratio of elements to each other in the compound. The definition of mass in units of gram and the mass of 1 mole of carbon. See, the first question, the ratio of chemical species to each other in the balanced equation. So in the balanced equation, chemical species, now for example, H2 plus Cl2, it gives HCl, that is 1 mole and 1 mole. So that is ratio of chemical species to each other in the balanced. This will not be the correct option because this is a normal, this is converted one. This will not be the correct option. And the second option, ratio of elements of each other in a compound. So this also will not be applicable because they have mentioned it is a ratio of elements. Here they did not mention in that way ratio and all. Right? This also will not be the correct option. Definition of mass in units of grams. Here what it is, they mentioned very clearly mole inverse. They did not mention any mass, given mass by molecular mass. It is actually gram. They did not mention in that way kg, nothing. It is mole inverse they mentioned, right? Now that the mass of 1 mole of carbon, see, 1 mole of carbon, even first question also it is 6.02 into 10 to the power of 20 molecules of urea, it has mentioned first question. The same thing only here also, 1 mole of urea, this is, that means here 6.022 into 10 to the power of 20 mole inverse. So that means that element, that is what it is, the mass of 1 mole of carbon. This will be the correct option. Why? Because mass of 1 mole of carbon, this is mass of 1 mole of carbon. In that way we can identify. So if suppose if we are calculating this point here, what it is, 1 mole of carbon, 1 mole of carbon, it is 6.023 into 10 to the power of 23. So in that, here atoms will be available. In that way we can identify. Therefore 1 by 6.023 into 10 to the power of 23 into 6.022 into 10 to the power of 20. The same idea only. First question also we have gone through in that way. So what is the option you will be, what is the answer you will be getting? 10 to the power of minus 3. So this only you will be getting the answer. So actually, which is the correct option? Option D. D. What it is? The mass of 1 mole of carbon. So it might be changing due to that some reason. So which is the correct option? See how tricky way. It's very simple question. How tricky way they are asking. It's very simple, right? So you be thorough in your concept. Then you are able to identify the answer. Come on, let's go to the next question. Grams of magnesium carbonate sample decomposes on heating to give carbon dioxide and 8 gram of magnesium oxide. What will be the percentage purity of magnesium carbonate in the sample? This is very simple and logical way thinking also it is available. Now you see here magnesium carbonate, it is a sample. So magnesium carbonate, see here magnesium carbonate sample decomposes. You are getting what it is, magnesium oxide plus carbon dioxide. Here 1 mole of magnesium carbonate produces, that is decomposes 1 mole of magnesium oxide plus 1 mole of carbon dioxide. Okay, now they have given that atomic weight also. Okay, let us check molecular mass of magnesium carbonate sample. That is actually 24 plus 12 plus 16 into 3. So altogether, how much? 84 gram per mole molecular mass of magnesium carbonate. And here, how much it is? 24 plus 16. Here, how much it is? Here, 40 gram per mole. Right. Now, in the question, here, 84, yeah, before going for 84 gram per mole, 1 mole of magnesium carbonate can produce 1 mole of magnesium oxide. So 84 gram per mole can produce 40 gram per mole of magnesium oxide. So therefore 20 gram of magnesium carbonate sample, it is providing how much it is? 8 grams. See here they have given that what it is here, 20 gram of, this is given mass, 20 gram of magnesium carbonate can produce here 8 gram of magnesium oxide. Okay, now let us think how much it is providing, right? So 84 gram of magnesium carbonate can produce 40 gram of magnesium oxide. Therefore 20 gram of magnesium carbonate. So 20 gram of magnesium carbonate, how much it can provide? Let us check that. So here in this point here, yeah, it is 40 divided by 84 into 20. Right, now that means here how much we are getting here? Here as we calculate it, no, you will get 9.52 gram. Right, so 20 gram of magnesium carbonate can produce 9.52 gram of magnesium oxide. That is actually what it is. Pakka answer. That is theoretical value. Theoretical value. Why I'm bringing the theoretical value point over here, because they have given the point what it is, 8 gram. Actually 8 gram, it is actually actual value. Actual value. This is theoretical value. Now we are going to check the mass purity. That is what the question. So the percentage purity. So percentage purity, you know the formula, actual mass of so and so divided by theoretical mass of so and so, right? So actual mass of MgO, that is what they have given now in this question. Actual mass of MgO divided by theoretical mass of MgO into 100 percentage, no, 100. So actual value what it is, 8 grams. Theoretical value how much? It is 9.52 gram. So 8 gram by 9.52 gram into 100. So how much you are gaining when you are calculating? You are getting 84 percentage. So the purity of mass purity. So the percentage mass purity, purity of magnesium carbonate. How much it is? 84%. I hope you got the clarity. What are the steps we are following? See, if you are writing that balanced equation only, 3/4 answer you will be knowing that. See, here 1 mole and here 1 mole. The same way here what it is? Molecular mass. So here also molecular mass. Then following data. Then we are identifying what it is? 40. That is what it is. Molecular mass of magnesium oxide divided by molecular mass of magnesium carbonate into 20 gram. That is given. It is actually a cross multiplication. So that's what I did not write that mention. Actually, you know that is what I'm explaining now. Okay, so 40 by 84 into 20. So you are getting, this is actually theoretical value what we are calculating according to that point. But what they have given, it is 8. So we are going to get that idea about purity of that sample. So the sample actually 84% purity. Now, which is the correct option? Option B is the correct option. See, option B is the correct option, 84%. Hope you got the clarity, and it is a repeatedly asking question. So this kind of question, like purity of purity of sample, I just mentioned, because in some other value also they will give, some other molecular formula also they'll give. So according to that, you please note down how do we identify. Come on, let's go to the next question. See, concept it is same, value will be vary. So concept you hold tightly, right? So that you can solve the problem very easy. Come on. Of solute in 1 m, that is molality, aqueous solution. This is very simple but tricky way they asked. Okay, come on, let's discuss this question. 1 m, 1 m, that is molality, small m, it is molality, represents molality. Aqueous solution, right? So 1 m aqueous solution represents what it is? 1 mole of solute, 1 mole of solute divided by 1 kg of water, right? 1 kg of water. That is what now molality means. What it is? 1 mole of solute divided by what it is? 1 kg of solvent. It is. So that is only solute and solvent. 1 kg of solvent, right? Okay. Now moles of water. Let us think moles of water. So how do we identify moles of water? That is 1000 gram divided by 18 gram per mole, right? See, 1 kg of water, it is solvent. It is molecular mass only, no, given mass by molecular mass. So in that way only we can bring. So here, what is the value? You are getting approximately 55.56. Okay, mole. We got it. Right now, total moles of solution. Let us think total moles of, because mole fraction is there, no. So mole fraction means total moles. So total moles of the solution equal to sum of the moles of solvent plus solute, sum, sum of the moles. That is only that mole fraction, right? So sum of the moles of solvent plus solute, right? Okay, now mole fraction, let us go for that idea. So mole fraction is equal to mole fraction so mole fraction of solute equal to moles of solute divided by total moles. So total moles, how much we have received? This much only, no. So that means here moles of solute, we can think it is 1, right? So 1 by 55.56. So what is the answer you will be getting when you calculate it? 0.017, right? 177 also, one more 7. Right, answer it is there. So the mole fraction of solute in 1 m aqueous solution approximately. So this is when you're calculating directly, you would have got it. This is actually a number of times repeatedly asking question. See, what it is. Generally, if suppose they are asking that question about what it is, water, number of moles of water, 1000 by 18, it is a mandatory answer, repeatedly asking. So that is what directly we are going for it. Okay, now what is that point? We have to write it here. The mole fraction. So mole fraction of the solute in 1 m, small m, aqueous solution approximately. It is not completely, it is approximately, because the number it is going approximately. So here how much it is? 0.0177, right? So there is no unit for mole fraction. So what is the correct option? Option B is the correct option. So option B, 0.01117. So this is option B is the correct option. Come on, let's go to the next question. It formed when 50 ml of 16.9% solution of AgNO3 is mixed with 50 ml of 5.8% sodium chloride. See here, they are asking about that product mass. What is the mass of the precipitate formed when 50 ml of 16.9% of solution of silver nitrate and sodium chloride? Let us write the balancing equation so that we can get that idea. So AgNO3, silver nitrate plus sodium chloride. So what is the product you will be getting? AgCl what it is, AgCl plus here what it is, Na NO3. Okay, displacement reaction. See this, as you are looking at that only, it is displacement reaction. Okay, is it balanced AgNO3 and NaCl? Just ulta. This one which is going to sit over here, this one which is going to sit over here. So it is displacement reaction. Come on, in that data also we can write it. So data what it is, 50 ml, both are 50 ml only. This is also 50 ml, this is also 50 ml, right? And here what it is, 16.9 percentage of silver nitrate solution mixed with 5.8 percentage of sodium chloride solution. So now here we have to identify the mass of the product. What is the mass of the product? Here mass of the product only silver chloride. So come on, let us find that complete idea about. So mass of silver nitrate. So mass of silver nitrate, AgNO3. So mass of silver nitrate here 16 percentage only, no, 16.9 divided by 100 into 50 ml, right? So how much you are getting the answer? And the same way mass of sodium chloride. So mass of sodium chloride. So mass of sodium chloride, how much? Here the same, 5.8 divided by 100 into 50 ml. So come on, let us solve this. This is how much you are gaining. This is actually value, it is 8.45 gram, right? 8.45 gram mass only, no? So gram. And the same way when you calculate, this is 2.9 gram. Easy while calculating. See, this is 5 ones are 5, 5 2. This is, when you calculate this, you are getting 2.98. And the same way this also. This is 1 and this is 2. And when you calculate 2 ones are 2, this is 8. 8 twos are 16 in that way. Okay. So, right. Now you got the answer. So, mass of silver nitrate and mass of sodium chloride, you got it. Now, how do we calculate it? Mass of what it is, silver nitrate, complete idea about this value. Okay. So, mass of silver nitrate here again. Generally, mass of, this is from that what it is, equation and data. Generally, mass of AgNO3. So, Ag it is 107.8. 107.8 plus nitrogen 14 plus oxygen 16 into 3. So altogether it is 169.8 gram per mole. Right. Okay. Now these points and they will provide nothing to worry, but you remember silver, how much, what is the mass? Because many times even when you go for electrochemistry and silver nitrate, it is mandatory that you should know, right? Okay, come on. Mass, number of moles, let us identify, because here mass we have find it, no. So number of moles we have to identify. So number of moles here. Number of moles equal to, yeah, change the color. So number of moles of AgNO3. So given mass, how much? Here just now we found, no, given mass it is 8.45, no, given mass, right? So 8.45 divided by molecular mass, how much? 169.8 gram per mole. So how much you will be getting, you know, it is 0.04976 mole, right? And the same way number of moles of sodium chloride. So number of moles of sodium chloride, that is 2.8, right? So 2.8 divided by, here molecular mass how much? 58.5. So sodium and chlorine, you know very well. Sodium it is, and chlorine 23, and chlorine 35.5. So this is 58.5. So you will be getting the answer here 0.04957 mole. Why I'm mentioning here 76, here 57, but other than that it is easy. Now in that, which is limiting reagent, easily you can identify which is limiting reagent. This is silver nitrate and this is sodium chloride. This is 0.04976, this is 0.04957. 57, it is smaller than 76. So the sodium chloride, it is a limiting reagent. Why I'm mentioning here limiting reagent? Because wherever it is data it is there, so that easily we can identify. So that is what. So this is limiting reagent. Yes, fine. Okay. Now next point I'm mentioning about the main question, what they are asking. Molar mass of AgCl. That is what they are asking, that no, what is the mass of this product? So that is what they are asking. No. So you know silver very well. So 107.8 plus chlorine 35.5. So altogether how much you are getting? 143.8. Yeah, not 8. It is 1.38 plus 5. It is, oh yeah, 143.3 gram per mole. Sorry, gram per mole. So molecular mass of silver chloride, it is 143.3 gram per mole. Yes, fine. Okay, now we are going to find that what it is, product, that precipitate. This is silver chloride, it is a precipitate. Mass of this product. So here how much we are receiving? 0.04957. No. So 0.04957 into 143. For AgCl, we are getting from NaCl only, no. Cl, it's getting here only, no. So 143.3. So you are getting the answer when you calculate this. So you are getting what it is, 7.11 gram you will be getting. So 7.11 gram. Okay, so mass of the product, mass of the product, how much it is? 7.11 1 so gram, that is okay. Now AgCl only is the product, that is what I just mentioned. See, that is what always we used to write that equations, that will come to know. Okay, come on, see, so if you are writing that balancing equation, see, so much it will be useful. See, you are getting that molecular mass, from that you are getting what it is, number of moles into molar mass, so you are getting how much, what it is, the simple idea. So number of moles equal to given mass by molecular mass. So molecular mass, you know very well that you are getting from here. Number of moles also we found what it is. It is number of moles, we have gone through this step, second step. In this step we have found no number of moles. Okay, now we are going to find that given mass. So given mass, how do we identify? Number of moles into molar mass, if you calculate it, so you are getting given mass. So it is actually 7.11 gram, it is 7. Yeah, so which is the correct option? 7 gram. Hope you got this concept and this idea of this question. Yeah, come on. Let's go to the next question. The elements X and Y combine to form two compounds XY2 and X3Y2. When 0.1 mole of XY2 weighs 10 gram and 0.05 mole of X3Y2 weighs 9 gram, the atomic weight of X and Y are. This is going around the neck actually, but it is actually easy. Come on, let us write the data clearly so that it will be easy for us to analyze the question. So first and foremost, capital X, Y, 2. So this is moles, number of moles, how much they have given, 0.1 mole. And weighs how much, that means mass, how much they have provided, it is 10 gram, right? That is what it has mentioned, no? Okay, now the same way, X3Y2, how much mole they have given, 0.05 in that half, okay, mole, right? Now in how much gram it has mentioned, 9 gram, right? Okay, now we have to identify that atomic weight of X and Y. So atomic weight of X and Y, let us write capital X and capital Y. We can consider small x and small y, so that easily we can analyze that answer. So here molar mass of X, here capital X, Y2, it is small x plus 2y, right? In the same way, molar mass of X3Y2 will be 3x plus 2y, right? Okay, now let us go for number of moles. So number of moles equal to given mass by molecular mass. So given mass, number of moles of XY2. So here 10 gram divided by molar mass, what it is, x plus 2y, right? So x plus 2y, we can bring it over here. So where, here, so here molar mass of XY2, it is, that is actually x plus 2y equal to 10 by 0.1. Here number of moles, it is 0.1 only, right? So this is actually 100. Just make it a whole number, you just put it 0 0, so automatically you will get 100. Here 1, here top 100. So here, so x plus y, so first to one, x plus y, that is 2y equal to 100. So this equation we can keep it as equation 1, right? Now the second equation, the same idea. So molar mass of X3Y2 equal to, here 9 gram, given mass it is 9 gram, no? Data we have analyzed. So 9 gram divided by number of moles, we can bring it over here. Number of moles, 0.05. So how much you will get it? When you calculate it, here 180 you will get it. So that means here x, 3x plus 2y. This is what you will be getting here, no? Molar mass of 3x plus 2y, right? Okay, so 3x plus 2y equal to 180. This equation is equation 2. Okay, now equation 1 and equation 2 you have to subtract. So equation 2 minus equation 1. Why we have to subtract? Then only we'll get that x and y, then we can find that atomic weight, atomic mass, right? Okay, right. Now here equation 2, 3x plus 2y equal to 180, and equation 1, x plus 2y equal to 100. Right, 100 only, no? Equation 1 and 2. So now you have to subtract both the side. So when you subtract, what you will be getting, here minus, here minus, here also minus. So 2y plus and minus cancel. So here 3x minus x, 2x equal to here 80. So 2x equal to 80, right? So that means x equal to 40. Now this x value we found. Now we can apply this value into equation 1. So here x plus 2y equal to what it is, 100, right? So x is 40 plus 2y equal to 100. Okay, now that means 2y equal to 100 minus 40. So you will get 60. So 2y equal to 60. 2y equal to 60. That means y equal to 60 by 2. You will get 30. So here y you got, y how much? It is 30, x equal to 40. So you're getting 30 and 40, x and y. So x is 40. Now you see, x is 40, y is 30, right? This is this much only, but prolonging, no, going around the neck, but it is very easy. 40, 30. X is 40, y is 30. You're 40 and 30 in that way. Okay. Right. So 40, 30, no. First answer 40, 30. Yes. So option A is the correct answer. Yes. Right. Okay. Hope you got that idea how to analyze it. See, first and foremost, while reading the question, you just analyze it and write the data correctly. When you're writing data correctly, 3/4 answer you might have known very well. Right. Okay. Come on. Let us go to the next question. The next question, which of the following is dependent on temperature? Molarity, mole fraction, weight percentage, molality. Right, now here, molarity, when we are talking about molarity. So this is actually dependent on temperature. This is dependent on temperature. Why I'm telling this is dependent on temperature? What it is molarity? Molarity, it is number of moles of solute divided by volume of solution in liter. So volume can be changed. In temperature. Now, 1 cup of water you are keeping on the stove means, well, boiling that water, automatically the water is evaporated. So volume can be changed due to temperature. Okay, so molarity dependent on temperature. Hope you got the clarity. Okay, now mole fraction. What about mole fraction? Mole fraction, it is a ratio of the moles. This is completely ratio of the moles, right? Okay, now ratio of the moles, so it will not ratio only, right? So it will not affect by temperature. And the same way, weight percentage, this also represents ratio of the mass. This is also ratio of the mass, right? This is ratio of the moles and this is ratio of the mass, right? Molality, it is number of moles of solute, what it is, per, that means divided by kg of solvent, 1 kg of solvent. So it is ratio of the masses only. So it is also independent on temperature. So this is also what it is, independent on temperature. Independent, not dependent, independent. So everything based on ratio of the moles, ratio of the mass, and this also represents what it is, ratio of the masses, because solute is different from solvent. So they are differentiating both molality, but molarity, what it is, it is completely based on volume. Okay, so volume, it is dependent on temperature. Due to temperature, volume will be changing, decreasing or increasing, right? Okay, hope you got that idea. So option A is the correct option. Okay, come on, let's go to the next question. 3 gram of formic acid and 4.5 gram of oxalic acid is treated with concentrated H2SO4. The evolved gaseous mixture is passed through KOH pellets, weight in gram of that remaining product at STP. Actually, let us write that equation so that it will be easy for us to analyze this question. Now, formic acid. So, formic acid, HCOOH, right? So, HCOOH. It is treated with what it is? Concentrated H2SO4. H2SO4. So, concentrated H2SO4 actually dehydrating agent. So, definitely what it is? It absorbs water. So, here, when you treat with this concentrated sulfuric acid, so you will get carbon monoxide plus water you'll be getting, right? Okay, now next to one more point, what it is, the same thing here, oxalic acid, COOH, single bond COOH, this is oxalic acid. This also you are treating with what it is, concentrated H2SO4. So here also releasing water. So here what are the products you are getting? Carbon monoxide, carbon dioxide and water, right? So you are getting water also, right? H2O. Okay, now let us identify that. What are the points here we have to note down? Here, first and foremost, they have given that given mass. So given mass 2.3 gram of formic acid. So formic acid, how much? COOH, right? HCOOH, how much it is? 2.3 gram given mass. Molecular mass, it is very simple. Hydrogen, two hydrogen is there, one carbon is there, and two oxygen is there. So here what it is? 46.03, right? 46 you'll be getting, right? 46. So you will get, what is the answer here? Suppose you are removing that point, no? So you'll get 1 by 20. Right. So 1 by 20 moles. So initially here you will be getting what it is when the reaction starts. It is 1 by 20 number of moles. So you'll be getting starting point 0, 0. After that, you'll be getting what it is 1 by 20. Here also 1 by 20. And the same way, this point HCOOH, COOH, single bond COOH, that is oxalic acid. So oxalic acid given mass, how much it is given mass? Given mass, it is 4.5 gram. So 4.5 gram number of moles we are calculating. Given mass 4.5 gram divided molar mass, how much? Molar mass, it is 90. We are not taking what it is, all those points only, oxalic acid molar mass only we are taking. So how much you are getting? Here also the same, 1 by 20. So 1 by 20, it is number of moles. So starting here you will get 1 by 20, and then here also you are getting what it is, after finishing that reaction, here also you'll get 1 by 20, and here also you'll get 1 by 20 carbon dioxide. Okay, now Next point, it's very important. Carbon monoxide and carbon dioxide are gaseous mixture passed through KOH. Now you see this is very, very important. Okay, now here what is the point I wanted to mention? Here gaseous mixture, no, carbon monoxide, carbon dioxide. So this is actually gaseous mixture. So passed through that, what it is? KOH pellets. So what happened here? CO2 will be absorbed. CO2 will be absorbed. Absorbed by water, KOH pellets. Then which is remaining? Which is remaining? CO only, it's remaining, right? So CO, it's remaining means what it is? Remaining products. Remaining products, it is CO only. So how much is CO? So this will be taken out by KOH. In that question also it has mentioned what it is. The evolved gaseous mixture is passed through KOH pellets. So that means this is absorbed. It has swallows carbon dioxide. Then remaining, here also CO it is there, here also CO it is there. Okay, come on, let us find that number of moles of these both. Okay, so here what it is? Remaining products. Remaining products. So remaining products, what it is? CO. Remaining product, it is CO. Okay, now number of moles. Number of moles is what it is? 1 by 20 plus 1 by 20, both the side, right? So here altogether 2 by 20. So number of moles also is there. And molar mass of carbon monoxide. Molar mass of carbon monoxide, how much it is? Here 12 plus 16, how much it is? 28, right? 28 gram per mole. Okay, now we have to identify given mass, right? Given mass only. So number of moles also it's there. Molar mass also it's there. Given mass equal to molar number of moles into molar mass. Number of moles into molar mass. Molar mass. So what is the answer you'll be getting in this? Here molar mass na. So here what it is? 2 by 20 into here 28. So how much you will get? Here 1, here 10. So here 10 means here 2.8. 2.8 grams. So given mass, it is 2.8 gram. Given mass, it's 2.8 gram. Hope you got that idea. Easy, but going around the neck. So only thing, if you know the data and applying through that formula, it will be easy to identify the answer. Now, which is the correct option? Option A. It's here and there like it is showing. So A is the correct option. Hope you got the clarity how to identify. Yes. Come on, let's go to the next question. Next question. In which case is number of molecules of water maximum? See, so many questions we have gone through. That is number of moles instead of number of molecules. The same idea only. Number of moles is directly proportional to number of molecules. Okay, now come to that point, which is maximum in that amount. Here 0.00224 liter of water vapor at atmospheric pressure and 273 Kelvin and 0.18 gram of water and 18 ml of water. Here 10 to the power of minus 3 mole of water. See, this is same idea only, but values are vary. Okay, now first and foremost 0.00224 liter of water at STP. At STP, right? Standard temperature and pressure. Now here 1 mole of any gas. 1 mole of any gas, how much it is? 22.4 liter. Okay, therefore this one, so that is actually, how do we calculate it? 0.00224 divided by 22.4 liter. So here 10 to the power of minus 3 water molecules, mole of water actually. This is mole, no, given mass by molecular mass, like, okay, so this is given value, this is mole of 1 mole of any gas. So this is mole of water, right? So this value you just safeguard for it, because we have to compare now for all these four. Okay, now the second one, what it is? 0.18 gram of water. 0.18 gram of water, it is very simple. Here 0.18 gram. Given mass by molecular mass, what it is? 18 only. So molecular mass 18, here 0.1 mole. Right. Now next one, 18 ml of water. 18 ml. 18 ml is actually what it is. Here, density of water 1 gram per ml. Right. Density. Density of water. It is density of water. It is 1 gram per ml. So we can keep it as, I'm just bringing this side over here. So 18 ml, we can consider 18 gram. So 18 gram by molar mass of water, it is 18 only. So what it is? 1 mole of water, right? Okay, now the last one, 10 to the power of minus 3 mole of water. The same idea here also. Okay, now which is the correct option here? First one, what it is? Here 10 to the power of minus 3 mole, right? 18.18 gram of water, it is 0.1 mole. right? Here, this is 1 mole, 18 ml of water, it is 1 mole, right? This also point, yeah, this is 10 to the power of, sorry, this is 10 to the power of 10 to the power of minus 3 mole, the same. Well, first and last the same. So in that, which is highest means 1 mole only highest. This is 0.1. This is 10 to the power of minus 3. That means 0.001. Okay, now which is the correct option? In which case the number of molecules of water is maximum. So number of moles is directly proportional to number of molecules. So that means C is the correct option. Hope you got the clarity. Same idea, different values. Okay, come on, let's go to the next question. Number of moles of hydrogen molecule required to produce 20 moles of ammonia through Haber's process. And this is evergreen question. One or the other question in ammonia Haber's process, definitely the question will be mandatory in all the competitive level questions. Right now, come on, N2 plus 3H2, it gives 2NH3. So here what they have given, 1 mole of nitrogen combined with 3 mole of hydrogen, it gives 2 moles of ammonia. 2 moles, I just mentioned here, 2 moles. 2 moles of ammonia. Right. Now here they are asking the question, number of moles of hydrogen molecule required to produce 20 moles of ammonia. So 3 moles of hydrogen can produce 2 moles of ammonia. So that means how many a number of hydrogen mole required to produce 20 moles of ammonia. So here 20 moles of ammonia we need. Here 20 moles of ammonia we required. So that means how many moles of hydrogen? That is the question. Okay, now cross multiplication. This is very simple. Cross multiplication. So how will you produce this? So 3 moles of hydrogen divided by 2 moles of ammonia. 2 moles of ammonia. So data also I'm just bringing to you so that it will be easy to understand. Into 20. Cross multiplication. 20 moles of ammonia. See here, 3 moles ammonia can produce 2 moles of ammonia. Therefore, 20 moles of ammonia, we have to get. That means how many number of moles of hydrogen required. So in that, how do we bring it here when you calculate it? So here 2 ones are 2. Here what it is 10. So how much you will get it? So you will get 30. So what is it? 30 moles of hydrogen required. So 30 moles of hydrogen can produce how much moles of ammonia? So 30 moles of hydrogen require to produce 20 moles of ammonia. 20 moles of ammonia NH3, right? Now which is the correct option? Hope you got that idea. How do we calculate it? Here option C, 30, it is the correct option. Yes, got it. 30, right?